Science friends, we are taking a deeper dive into our solutions lesson today and talking about percent solutions. So oftentimes when we're dealing with solutions, you will be told to make a 70% solution of hydrogen peroxide or make a 5% solution mass by volume of albumin. And so how do you make those solutions? Okay, so that's what we're going to talk about. So percent by volume is one way that you can make a solution. And this is really the only notes page today, so I do want you to copy this down because you'll need this as you go into your practice problems here in a minute. But percent by volume is used when you have a liquid solute and a liquid solvent. So two liquids are going to use a percent by volume. Percent mass per volume is when you have a liquid plus a solid. Okay, so if you're introducing a solid in there for your solute, then you're going to have a percent mass per volume. All right, so let's talk about these for example. So the first one I said, if you have a hydrogen peroxide. So if you buy hydrogen peroxide at the store, I think I may have used this example the other day. It's like a 3% hydrogen peroxide solution. So that means there's actually 3 milliliters of hydrogen peroxide. That's the formula for hydrogen peroxide per 100 milliliters of the total solution. Okay, so if you're making that, basically what you're going to do is take 3 milliliters of hydrogen peroxide and 97 milliliters of water, and that makes a 3% hydrogen peroxide solution. Okay, that's how you would do that. It's very simple. Now, if you go to the hairdresser and they use hydrogen peroxide to like highlight your hair, chemically lighten your hair, then that's going to be like a 30% hydrogen peroxide solution. So instead of 3 milliliters of hydrogen peroxide in 100 milliliters of solution, it's going to be 30 milliliters in 100 milliliters of solution. So I'm saying in 100 milliliters, that means your total volume is 100 milliliters, okay? 3 plus 97 of water, or 30 of hydrogen peroxide plus 70 of water for a 30% solution, okay? And so that would be a 3% hydrogen peroxide solution is how you would do that, okay? Now, let's talk about if we have a solid, for example. So maybe you're making a saltwater solution. And so if you were making a 5% saltwater solution, sometimes they'll tell you that to use a 5% saltwater solution to gargle with if you have, or to, clean your braces or something. I don't know, I never had braces. But sometimes you will have to make solutions like that. They'll say to sterilize things and to clean things. So that would mean that we need 5 grams of salt of our solute per every 100 milliliters of solution. Okay? So if you were making that solution like we talked about the other day, you would fill your flask or beaker or whatever about halfway up with water, add 5 grams of salt, and then bring that volume on up to 100 milliliters, okay? Unlike this one where we can easily subtract and see we're going to need 97 milliliters of water, you can't really do that with the salt because 5 grams may displace more than 5 milliliters, if that makes sense, okay? So that would be a 5% saltwater solution. 5 grams of salt per 100 milliliters of water, okay? So let's take a look at a couple of practice problems with these. So the first one says, what is the percent by volume of ethanol, C2H6O, in the final solution when 85 milliliters of ethanol, so there's our solute, is diluted to a total, we'll say total volume, that's probably a better way to word that, of 250 milliliters with water. Okay, so we have a 250 milliliters total solution. And then we're going to have to multiply by 100 to get our percent. So if you take 85 and divide it by 250, you should get 0.34, I think. And then if you multiply by 100, then that would be a 34% ethanol solution. Okay? So adding 85 milliliters of ethanol and bringing to a total volume of 250 milliliters with water would make a 34% ethanol solution. All right. Let's look at one more here for a mass volume solution. And sometimes you'll see mass volume written like this, M over V. These would be written as V over V, a volume solution, or a mass volume solution. Okay. So it says, how many grams of glucose, C6H12O6, would you need to prepare 2 liters of a 2.8% glucose mass per volume solution? So remember, 2.8% glucose means 2.8 grams of glucose per 100 milliliters of solution. So we need to make 2 liters of solution. Well, if you remember that 1,000 milliliters are in a liter, then that means there's 2,000 milliliters here, okay? So if we multiply that by 2,000 milliliters, okay, our solution is that solution that we're going to try to totally make. That's going to cancel out, okay? And so we're left with 2.8 times 2,000, and then we have to come down here and divide by that bottom part, divided by 100. And so what that should give us is 56, and then we still have our units right here, grams of glucose. And that's what our question asks us. How many grams of glucose? And so there's our answer, 56 grams of glucose. All right. So I have 2 practice problems for you to try here. So go ahead and pause me and try these 2 practice problems, and then start me back up when you're ready to check your answers. All right, let's take a look at these together. So the first one, you should have gotten 12 milliliters. The second one, you should have gotten 0.25 grams, okay? So the thing that you really need to remember is that you have to convert those percentages back to a decimal. So 3% is equal to 0.03. 0.1% is equal to 0.0010, okay? And so if you set that up as your percent on the left side, okay, and then you're setting that equal to the, let's just look at one at a time. So 0.03 is the percent, and we are wanting to know how many milliliters of H2O2, and so that was this part, the X, okay, I just put X there, are in a 400 milliliter bottle. And so then we cross multiplied 0.03 times 400 left me with 12 milliliters, okay? Now, I went back to check myself just to make sure I did this right. So if I did this correctly, then if I put 12 milliliters in 400 milliliters of total solution and multiplied that by 100, it should have made my 3%. And that worked out. When I did that in my calculator, I got 3, and so I knew I worked my problem correctly, okay? Same thing with the bottom here. We had to convert that percent to an even smaller decimal. So we put it on the left side of our equation. I set it up as X grams because that's what we were trying to find out, how many grams of solute were required. 250 milliliters of total solution. Again, we cross-multiplied 0.0010 times 250, and that left me with 0.25 grams. And so that is your answer on that one, okay? If you have any questions, let me know, and if not, then you all have a great day.